All right, let's practice some examples for conservation of energy. We're going to pretend that there is no air resistance. In this case, we're with a diver who is landing into water a certain height below. Let's say he's a daredevil and goes off a height of 10 meters. There are options. Let's go, if he just steps off and initial velocity is 0. B, if he jumps off with about 5 meters per second. This means that kinetic energy initial was 0, and this means that kinetic energy initial is mv squared over 2, and it's initial over 2. So whatever his mass is, let's say his mass is 50 kilograms. Then you would do 50 times 25, which is 5 squared over 2. And that would be the chunk of energy, joules, of kinetic energy that the diver will have at the beginning of his dive. Energy gravitational plus kinetic energy, and both of those would be initial. In the end, if he lands all the way in water, and I call this 0 level, so I'm going to say potential energy gravitational here is 0. So then potential energy gravitational here is going to be mgh. That's the formula for gravitational energy. And then finally, potential energy gravitational plus kinetic energy final. That is the general formula. That is your conservation of mechanical energy in this case, if there is no air resistance, no springs, and just a position above the ground and motion. Now we're going to use logic. So he does have initial gravitational energy? Yes. Kinetic energy in A? No, but in B, yes. And then finally, in both A and B, there is no gravitational energy left, and in both A and B, there is final kinetic energy. Now I'm going to use the formula mgh initial plus for this, for A is 0, so you can just drop this and say it's just gravitational energy initial. It would be equal to gravitational final is both 0. So then I'm going to say mv squared final over 2. Mass will cancel. And you're going to say v final squared equals 2gh initial. And therefore just v equals square root of 2gh initial. So with the numbers that we're given, it's going to be 2 times 9.8 and times 10. And that will be meters per second. And you can use your calculator and figure out what it is. This will be A. For B, it's the same beginning. It's mgh initial. But we also have to say that he has initial kinetic energy because he jumps, not just steps off the board, but jumps. And it will be equal to mv final squared over 2. Again, mass can cancel, and you're going to end up with, I'm going to multiply by 2 to get rid of the denominator, will be equal to v final squared. Should remind you of the old formula that we had in kinematics. So then v final is going to be a root of 2 times 9.8 times 10, and then plus 25. That would be your answer to final velocity if the person doesn't just step off the board but jumps off the board. Let's say I want to know how fast he is moving 5 meters above the ground. There are 2 things you can do. You can do this. Potential energy gravitational initial plus, if he steps off, then it's 0. If he does jump off, then you're going to have kinetic energy initial, and it will be equal to potential energy gravitational final plus kinetic energy final. Solve it C, where I have h initial of 10 meters, h final of 5 meters, v initial of 5 meters per second. mgh initial plus mv initial squared over 2 should be equal to mgh final plus mv final squared over 2. Masses cancel. Boom, boom, boom. And then we have 9.8 times 10 plus 25 over 2 equals 9.8 times 5 plus v squared final over 2. So ultimately we will subtract this from there, and it becomes 9.8 times 10 minus 5 plus 25 over 2. Then you will multiply all of this by 2 and square root, and that will get you your v final. You could use a shortcut and say, if this is your initial potential energy initial, which is mgh, and we want to figure out the kinetic energy over here, the difference between these two is just 5 meters. Well, then I'm just going to say that my zero level is here. That way, my final potential energy is 0. And that makes it much easier. So you will have potential energy initial plus kinetic energy initial equals just kinetic energy final. The trick there is to remember that your potential energy initial is 5 meters, mg times 5, because that is how much higher your beginning is relative to the final position. And then you will do the plus mv initial squared over 2 equals mv final squared over 2. 9.8 times 5 after we cancel masses plus 25 over 2 equals v final squared over 2. So go ahead and practice more examples of your own. So if you want to give yourself mass of the diver, give yourself height initial, give yourself v initial and height final, whichever way made more sense to you, use that one. Don't mix them up, or if you really want to, you can practice both.